Hello, and thank you for checking out the Six Sigma Tool Guide. Today we're going to take about 5 minutes, maybe 10 at the most, to talk about mean, median, and mode. This is part of an ongoing conversation on basic statistics. So let's go ahead and get started. Okay, what and why? As always, we start there. Basic statistics really help you get an understanding of your data, and hopefully this is a nice refresher and reminder on some of these really kind of simple first level basic things: mean, median, and mode. Those things give you a basic understanding of the process's current performance, and when you combine that with your customer's expectations, the upper and lower specification limits, these basic stats can help you get an understanding of the gaps between expectations and actual performance, and it can quickly give you a sense of how much variance there is in the process. We'll talk a little bit about how important variance is and get into it a lot more in part 2. So, the 3 M's of basic statistics. We're talking about mean, mode, and median. We have a data set here to the left. A data set is just a group of numbers that are individual observations. We can, for the sake of argument, say that this data set represents cycle time. And if we were to sum up the total of all of these observations, we would get a total of 27. So our mean is 2.7, our mode is 2, and our median is 2.5. And we're going to walk through how we calculated each one of those next. So the mean, this is the simple one. They're all simple, but this is the average. We all do this every day. Most of us are familiar with the term average. The mean is the sum of all the individual observations divided by the number of individual observations. So we're all pretty familiar with this. We have a data set right here. We add all these up, we get 27. We count how many observations there are. There are 10. So we have a count of 10 and a total of 27. So we simply take 27 divided by 10 and we get 2.7. That is our mean. Now this is often mistakenly thought of in the context of usually or most of the time, which is really not the case. We'll talk more about that. So here for now though, we're going to say we have a mean of 2.7 and that's how we calculated it. So let's move on to the lesser used metrics. So now mode. Mode is less frequently discussed. Mode is the value within the observations with the highest frequency. So here's that data set again. I've counted them out. There's 10 observations there. And those observations are all made up of values of either 2, 3, or 4. So if we just pretend this is cycle time, we can say these are instances where it took 2 days versus 3 days versus 4 days to complete some task. So we're going to count up the number of observations for each of these values. And so we're going to say, how many times did it take 2 days? Well, it took once, it took twice, it took 3 times, so on. We're eventually going to find out that in total there were 5 occurrences, 5 observations where it took 2 days. So then we say, how many times did it take 3 days? We're going to count all these up, and we're going to find that it took 3 instances where it took 3 days. And then finally, how many times did it take 4 days? Twice. So our number of observations, there's 5 observations under the value of 2, 3 observations under the value of 3, and 2 observations under the value of 4. The most frequent observation, the one that shows up the most times compared to the others, is 2. So our mode is 2. It's that simple. Now, mode is also often mistakenly thought of as usually or most of the time. It more accurately would be described as most frequently. It's not necessarily most of the time. In our example, our mode is 2, and that represents half of the examples in the data set. So that's not most. It's almost most, but it's half. And this, with a different data set, very easily the mode could have been something that occurs less than half of the time. So it is, again, a misnomer to refer to mode as the observation that happens most of the time. It's the one that happens the most frequently. All right, next up is median. Median is a figure we hear associated with the values of homes often. The reason for that is because there's so much variance in the cost of a house. The average is less meaningful. The median is a little more meaningful. But what it is it's the exact center point of the values. And how you calculate that is you start by sorting out your data by value from lowest to highest. That's what I've done here. Same data set, I just started with all the 2s and built my way up to the 3s and eventually up to the 4s. If you have an even number of values like we do, we're going to find the 2 values at the center, and that's why you'll notice in the number 5 and 6 position I highlighted this 2 and 3, because those 2 points are the exact center of my data. And so I'm going to find the mean, or the average, between those 2 numbers, the 2 and 3. So the mean is 2.5. If you have an odd number of values, the value in the exact center is your median. So in our case, our median is 2.5 because we had an even number of observations. We took the 2 center pieces and we got the average of those, and that gave us 2.5, so that's our median. If we'd had 11 observations, we could have just moved to whatever that value was in the exact center, and that would be our median. So in our data set that we've been looking at, the mean, the median, and the mode were all very similar numbers. This is our data set. Our mean was 2.7, our mode was 2, and our median was 2.5. Our data was very tightly clustered. There was very little variance. Every one of these observations was either a 2, 3, or a 4. So in this data set, as an example, I'm putting up a different data set with a large degree of variance. So these numbers range all the way from 2 to 99. Still just 10 observations, but lots of gaps in between the numbers. So in this case, the mean is 43.6. You might not know that just by glancing at the data. The mode is 6, and the median is 11.5. So you can see these numbers have almost no relation to each other, unlike our previous data set where they were very tightly clustered. The reason for this is because of variance. There's a wide gaps in the numbers that we have here, and that is manifests itself in wide gaps between the mean, the modian, and the median. So high levels of variance make these measurements a little less meaningful. And as you can see, as an example, we have the mode is 6. It only happens 2 or 3 times. Definitely not fair to say that happens most of the time. The mean is 43.6. Definitely not fair to say it happens most of the time because it actually never occurs. It's just simply the average. And our median point of 11.5, again, we have a range from 2 to 99. So we're all over the place. So this is just a kind of a refresher on mean, median, and mode. If you'd like to move on now to Basic Statistics Part 2, we're going to talk a little bit more about deeper stats, standard deviation, variance, and histograms, and really how you tie all these things together to get a better view of the process you are improving. Alright, so I'll see you over in Part 2.